Water and pH. Water is a unique liquid and it is crucial for life as we know it. Organisms are mostly water, but also a lot of our organisms depend on water for their body's chemical reactions. Many of water's unique properties are due to its polarity and it being a polar molecule. A water molecule is 2 hydrogen atoms and 1 oxygen atom, which is why we refer to it as H2O. It's also commonly nicknamed as the Mickey Mouse molecule because if you look at it, the 2 hydrogen atoms are smaller than the oxygen atom and it looks like a Mickey Mouse head. So let's talk about what polarity is, because we know that polarity is responsible for a lot of water's unique properties. So it is what is referred to as a polar molecule, meaning that it has an uneven distribution of charges. Even though the water is an electrically neutral molecule, the ends of that molecule have a slight charge. And this is because of how the electrons are shared between oxygen and hydrogen. Because oxygen has a larger nucleus, it takes longer for the electrons to travel around that nucleus. And it gives it a slightly negative charge because electrons are always negatively charged. And because it's sharing the electrons with the hydrogen electrons pull closer to the oxygen atom, and it gives the hydrogen end a slightly positive charge because the electrons don't spend as much time there. So how does this contribute to water's unique properties? Water molecules form a weak hydrogen bond. Hydrogen bonds are weaker bonds, and this causes the H2 molecules to be attracted to each other. So that polarity, those opposite ends are often attracted to each other because of the charges. Those weak hydrogen bonds are what enable water to have its unique properties because of the water being attracted to itself and other polar molecules. A water molecule has some unique properties, and there are some things that we're going to talk about with those unique properties. 2 of those things are cohesion and adhesion, and we're also going to talk about the density of water. Water molecules show cohesion. Water molecules are attracted to themselves. This causes a high surface tension and the ability for water to be resistant to changes in temperature. This is also why some animals, like a water strider, are able to walk on water, because what's happening is there's the cohesive forces that are between those molecules creating that surface tension. And animals like your water strider, they have little tiny hairs on there and they do not break the surface tension of the water, so they're able to stay on top of it. Water molecules also show adhesion. Adhesion is again due to the polarity of the water, and this is where substances are attracted to other substances. So those molecules are attracted to other substances. This is the property that actually allows for water to creep up thin tubes like a plant stem or go up into straw-like things. And when you're looking at it in this image, this is also what causes the curve in that tube, is that adhesion property. So, let's talk a little bit more about those unique properties. So, that adhesion where it will move through things, this is called capillary action, where we have water that can creep up thin tubes, like traveling up through the veins and the stems of plants. This is called capillary action. Water has a high surface tension, which is where the molecules are attracted to each other, and things don't always sink unless that surface tension is broken. Water has a high heat of evaporation, or high heat capacity, compared to other liquids. It takes a lot more heat energy to cause the water to evaporate. And then when the water does evaporate, it takes a large amount of the heat energy with it. So in terms of living things, this is also how humans maintain homeostasis. And when we sweat, the sweat evaporates and it takes some of the heat with it, maintaining homeostasis. So water does help us maintain homeostasis. Water is resistant to temperature changes. So if you even look at like our river during the winter, it doesn't freeze right away because the water has a lot of energy trapped in it, and it's going to be resistant to those changes. And it's going to take longer for it to lose those temperatures than the outside air. Water expands when it freezes, and this increased volume means that ice has less density than liquid water. So this is why ice floats. So you have a chart there on your notes. I would like you to take a moment and fill in your chart on your notes to reflect what you see in the image here of the properties of water. So to wrap this up, water is a polar molecule, which causes it to form hydrogen bonds. This bonding causes adhesion and cohesion, which create water's unique properties. Now we will begin to talk about solutions and pH. So a solution is where one substance gets dissolved in another. Every solution has two parts, a solute and a solvent. A solute is what is being dissolved in the liquid, and the solvent is the substance doing the dissolving. And normally this is a liquid. Water's polarity allows it to dissolve many types of solutes, including salts, minerals, and gases. It is often referred to as the universal solvent. Some particles cannot be dissolved in water, but they can be suspended. So think about the creek outside. When there's a bad storm and it gets muddy and murky, and there's twigs and branches and rocks and debris, and you see all that stuff floating in the water, that is a suspension, or the stuff is suspended in the water. Suspensions will settle into layers over time. In a solution, we don't see that. We see the particles being dissolved throughout. We're going to begin now to talk about acids and bases. Water molecules can separate into hydrogen ions and hydroxide ions. These are charged particles. So water can separate into these ions when they're in a solution. They can also combine back into water. Because water forms an equal amount of hydrogen and hydroxide ions, it is considered to be a neutral solution. All neutral solutions have a pH of 7. So when we talk about what is an acid and what is a base, an acid is a substance that has a higher concentration of hydrogen ions in a solution than water does. A base has a lower concentration of hydrogen ions, but it has a higher concentration of hydroxide ions. And that is what we base our pH scale on. Our pH scale is based on the concentration of the hydrogen ions in a certain solution. Our pH scale goes from 0 to 14. 7 is neutral in the middle. Our neutral solution would be pure water. As you go closer to 0, you become more acidic. The closer to 0 you become, the higher the acid is. Going from 8 to 14 on the scale are bases or basic solutions, and the higher you get towards 14, the stronger the base. So, solutions that are less than 7 are called acids. Solutions that are higher than 7 are called bases. Some general properties that we can see in acids are they normally taste sour. They will neutralize bases, meaning they will counterbalance a base. They often can corrode metals. Their pH is less than 7, and they have a high concentration of hydrogen ions. Bases we typically think of being slippery. They also normally taste bitter. They neutralize acids. They are often also known as alkaline. They have a pH higher than 7, and they have a higher concentration of hydroxide ions. In summary, water is called the universal solvent because many substances dissolve in it. It also separates into hydroxide ions and hydrogen ions equally. This means that water is a neutral substance, unlike acids and bases which have charged particles.